Good day, students. So on this clip, we're going to be going over an example on how to solve a 3x3 system of equations using matrices, and then I'm going to be employing the matrix functionality of the TI-89 to do the whole process, okay? So one thing you want to notice is that the algorithm I'm showing you, or the syntax I'm entering for the TI-89 is very similar to the 83, okay? I'll go over that in a minute. So in this clip, we're going to be trying to solve the system. We're going to solve the system x minus y plus z equals -4, 2x minus 3y plus 4z equals -15, 5x plus y minus 2z equals 12. Okay, so we have a 3x3 system. We're going to solve this using matrices, okay? There are other methods that can be used to solve this, but I just want to show you how to do this using the matrix operations in a calculator. So first thing I'm going to do is I'm going to find the related matrix of this system. So all I'll do is extract coefficients and place them in a matrix, all right? If a number doesn't have if a variable doesn't have a coefficient, I'm going to replace it with 1, all right? So you notice this x right here doesn't have a coefficient, so I'm going to put a 1 here, a 1 here, a 1 here, and then a 1 right here, okay? So let's go ahead and create the related matrix. I'm going to just extract the coefficients, all right? So that goes my matrix. I have 1, -1, 1, -4 for my first row. And then for my second row, I have 2, -3, 4, and -15. And then for my third row, I have 5, 1, -2, and 12. All right? Now, what I'm going to do is my goal is to make this matrix into a reduced row echelon form. Okay, when I reduce this matrix to reduced row echelon form, I'm going to get a matrix where the diagonals right here are 1, everything else is 0, and the answer on this side right here will be my answer. Okay, so the reduced row echelon form, goes on the side. Reduce row echelon form. Don't write this down because I just want to show you what my end result should look like. So the reduced row echelon form is going to be reduced row echelon form. Calculator calls it RREF. The reduced row echelon form is going to look like this. It's going to have, see, 1 as this 1 right here in a 0, 0. And you have a 0, 1, 0. And you have a 0, 0, 1. You have a 1 on the diagonals for 3 by 3. And on this side right here, whatever is here, that will be your solution. Okay? So what I'm going to do is I'm going to show you what the answer looks like, and then we're going to go through all the whole procedure to show you how to do it step by step. Okay, so this is 0, 0, 1, and then something here in the last column will be the solution. Okay, so what is that? Well, I don't know. Let me show you how to do that in the calculator, and then I'll guide you through the entire process. Okay, so first thing we're going to do is enter the matrix. So this is the syntax. I'll use a bracket right here next to the parentheses. This opens the entire matrix. To open the first row, I'll put another bracket, and then I'm going to go 1. It's going to be delimited by commas, comma, -1, comma, 1, comma, -4. Don't use a minus for the negatives, or else you get a syntax error, okay? Close the first row, open the second row, 2, comma, -3, comma, 4, comma, -15. Close the second row, open the third row, 5, comma, 1, comma, -2, comma, 12. Close the third row, and then close the entire matrix. Okay, let me go over my rows again just to make sure I made it correct. I entered it correctly. 5, 1, -2, 12. Okay, good. 2, -3, 4, -15. Good. Let's check row 1 just to make sure. 1, -1, 1, -4. Perfect. Okay. Now, what I'm going to do is I'm going to store this matrix. You see store right here in a variable. Let's store it in y, sorry. So I store it in y, press enter. Let's look at this matrix to make sure it matches what we have here. 1, 2, 5, -1, -3, 1, 1, 4, -2, -4, -15, 12. Perfect. Okay? So just to make sure you press Y and press enter again, see what comes up, the matrix. Now I'm going to do a command for the RREF of matrix Y. Okay? So to find all the matrix commands, you can press second function 5 to go to math. And then you go down to matrix. And you see this RREF right here? It's called reduced row echelon form. Scroll down to that. Option 4, press enter. Y, enter. Down. See, this is a reduced row echelon form, and it tells me that my solutions are going to be 1, 3, -2. So basically, x is 1, y is 3, z is -2. Okay? Now this is the shortcut. This is just a quick way of doing it. Okay, but how do we show it using row operations? If you wanted to do all the whole 9 yards of row operations with matrices, how do we arrive at this answer? So that's what I'm going to show you. Alright? Okay, so let's go ahead and get started. We're going to assume that we don't know what the answer is. Scratch that. So to get started, I'm going to use my row operations. I want to get this diagonal to be 1. And these are the numbers within this 3 by 3 area right here to be 0. So 1, 1, 1, everything else 0, and then whatever is here by my row operations will be my answer, as we can see over here. Okay? So just to illustrate the row swap, I'm going to swap row 3 and row 1 for you, so you can see the row swap function of the matrix. Okay? You don't have to do that, but I'm just going to do it. Alright? So I'm going to swap row 3 and row 1. So I'm going to write this command. Row 3 swap with row 1. Okay? So swap row 1 and row 3. That's elementary, right? I can do that by hand. I don't need a calculator to do that for me. But let me do it by hand, and I'll show you how to do it with a calculator, okay? So by hand, I'm going to have 5, 1, -2, 12. Row 2 stays the same. 2, -3, 4, -15. And then row 3 is row 1, 1, -1, 1, -4. Okay? Now, how do we accomplish that with a calculator? Now, what I'm going to do, we can go back to, another thing I wanted to illustrate is that this reduced row echelon form, every command in any menu is accessible in the catalog. So if I wanted a catalog, and I press R, and I went down, keep going down and down and down. Scrolling down, see that? Reduced row echelon form is also there of Y. Get the same answer. Okay? Now let me show you the row swap. You can find it in the catalog, but you can also find it in the matrix menu in math. So let's go back to math, second function math. Let's go down to matrix. What we're going to do is row swap. So to find row swap, we're going to scroll down to something called, where is it? Go up. Actually, it's option. Yeah, it's called row operations. See this right here? So let's go back again so you see it. So I go into second function, math, go down to matrix, and then I went all the way up to row operations, right? See the row swap right there? So you press enter. So I'm going to swap row 1. Well, let's indicate the matrix first. So for matrix Y, I'm going to swap row 1 and row 3. Okay? Press enter. See what I have right there? I did use the row swap command. I think a quicker way to do this is just go to catalog. If you know what the command is, you can go straight to catalog. Instead of going through that menu, you can just go straight to row swap. The syntax is you enter the name of the matrix, the 2 rows I want to swap, so 1, 3, like that, enter, and then you have this matrix right here. But if I press Y, it gives me the original problem, the original matrix. Why? Because I didn't change Y. I just generated a random matrix. So if I want to change Y, every command I execute, I must store my result in Y. So row swap matrix Y, row 1 for row 3, I have to store my result. I have to store my result in Y. Okay, enter. You see this? Now check this out. When I press Y, exactly what I want. So we are now in the same place. So where the calculator is and where I'm at line up. All right. Okay. Now what I'm going to do next is as follows. I want to um, I want to create all my zeros first. Okay. Create all my zeros first, and then I will go ahead and create my ones. Okay, so I want to create my zeros. I need to make this 0, make this 0, make that 0, make that 0, make that 0, make that 0, and then make that 0. Okay, so that's my initial goal. And then afterwards, I'll make everything else ones. Within this 3 by 3 right here. Remember, we are focusing our attention on just this 3 by 3, okay? I want, just to illustrate, I want to make this, so let me take that out. I want to make this 0, I want to make this 0, I want to make this 0, I want to make this 0. Uh-oh, mistake. 0, 0, I want to make that a 1, I want to make this 0, 0, 0, and then make these diagonals a 1. Okay? So let's create our zeros first. After creating our zeros, then create our ones. Okay? So that's the strategy I'm using here. There are different ways of doing it, but that's what I'm going to do in this example. Alright? So let's go ahead and get started. My first target is this 2 right here. I want to make this 2 a 0. So how do I make this 2 a 0? Using row 1, what I'm going to do is I'm going to multiply row 1 by negative 2/5. The negative 2/5 of row 1, and I'm going to add it to row 2 and store my answer in row 2. Okay? So what does this command here mean? This command basically means multiply row 1 by negative 2/5 and add to row 2. Why on earth am I multiplying by negative 2/5? Because if I multiply, look at this 5. If I multiply 5 by negative 2/5, what happens? It becomes the opposite of this, right? Because 5 times negative 2/5, the 5's cancel out, is negative 2. And if I combine negative 2 with 2, I get 0. And that's what I wanted. I want this to be a 0. Okay, so that's the goal. Alright, so let's do that with a calculator. Alright, so I'm going to use the matrix command. Let me go through the long way. So second function math, second function 5, scroll down to matrix, and then I'm going to go up to row operations, and then go down. You see this multiply? This M is multiply, row, and add. Okay? In the Ti-83, this is a star, row, and add. The same idea. But you need to know the syntax. Let's press enter first. So the syntax is, first thing you enter is whatever you're multiplying by, which is negative 2/5. And then you're going to enter the name of the matrix, which is Y. You're going to enter the row that you're multiplying by, which is row 1. And then the row that you're adding to. So it says multiply 1, add to row 2. Let's test it first before we store. Enter. Okay? Let's see what we got. Now, this hasn't been saved yet, so when I do this, I need to store it in matrix Y. Okay? Enter. So there we have it. The cool thing about the Ti-89 is it expresses everything in fractions, so I don't lose precision, okay? So I like it like this. This is perfect. So let's go ahead and write down our result. So it's gonna be what's it gonna be? After doing that command, we're going to have row 1 stays the same, 5, 1, negative 2, and 12. Row 2 becomes 0 here because of this thing that we did over here. 0, and then everything else becomes a messy fraction, negative 17/5, 24/5, negative 99/5. And then the last row, we didn't do anything to it, so we'll leave it alone. 1, negative 1, 1, negative 4. Okay? Alright. Now, if you notice, row 2 looks messy, right? How about we get rid of that fraction there so I don't have to keep writing fractions? You notice that the denominators are all 5, right? So if I multiply this whole row by 5, that would clean out the fraction for me, okay? So while we're at it, so we're going to multiply row row uh, row 2 by, let's multiply by -5 so that we get rid of this minus here. Because if I get rid of this minus, later on it's easier for me to just make it a 1, okay? So let's multiply by -5. So I'm going to do just -5 of row 2, and I'm going to store it in row 2, okay? If I do that, let me do that by hand because this is a piece of cake to do by hand. If I multiply row 2 by 5, -5, sorry. So let me write what this command means. This command means multiply row 2 by -5. Okay, to get rid of this fraction. And this minus right here, because that's a pain. So we're going to have row 1 stays the same, 5, 1, -2, and 12. Row 2 loses that 5 and the minus, so it has 0, +17, -24, +99. And then the last row stays the same, 1, -1, 1, and -4. Okay? Alright, let me do what I just did by hand with a calculator. Okay? So we're going to use something called multiply row. There's no adding here. So second function, 5, takes you back to the matrix menu. Scroll down, out. Oh, wait. Let's go back. Matrix, and I need the operations. Row operations. See this one right here? Option number 3 says multiply row. Okay, so I'm just going to multiply row blah by a certain constant. Okay, so let me show you how to get that in catalog. Just press catalog. It's multiply row m row, right? So I'll look for m. Just press the 5 button. That's m. Scroll down. Scroll down, 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 and out. There you go. Multiply row. So all you just need to do is enter what I'm multiplying by, the name of the matrix, and the row. Okay. So let's enter it. Press enter. So I'm going to multiply row 2 by -5, right? So enter what you're multiplying by, -5. The row is, I'm sorry, the matrix is y, right? And we're multiplying row 2. That's what we did over here. What was that? Let me test it first before I store. Just in case I messed up, I can go back and fix it, right? Press enter. Bam, exactly what I want. So let's store that in y. So see this matrix right here in this matrix? That's they're aligned, so good. Now let's shift our attention. Remember I'm creating zeros, right? I have my 0 here, good. Now this is the next target. I want to make this a 0. So in order to make this a 0, I'll multiply this by -1/5 to create a 1 and add it to this, and I'll make that a 0. Okay? Alright, what did I just say? Well, let me write it down. We're going to do -1/5 for row 1 plus row 3, okay? And I'm going to store this in row 3. Alright? So let me write this in word form. Multiply row 1 by -1/5, add to row 3. Okay? That's what I'm going to do. Now this is a little bit hard, so I'm going to use a calculator here. Alright, so make a matrix. We know that matrix 1 and 2, rows 1 and 2 do not change, so let's write them down. 5, 1, -2, 12, and then this one doesn't change either. 0, 17, -24, 99. This should be a 0. Let's keep our fingers crossed. If it doesn't come out to 0, then I messed up somewhere and we have to go back. So let's do that in the calculator. This is multiply row and then an add. Okay, multiply and then add. We're doing 2 operations here. So let's go to catalog, multiply row and then add. Enter. Remember the syntax. What you're multiplying by, which is -1/5. The name of the matrix, matrix y. The row that you're multiplying by, row 1. And the row that you're adding to, row 3. Okay, let's do a test before I start. Bam. There we have it. So let's see. Alright, so there we have it. Excellent. So you notice that there's a 0 here. That's what I wanted. So we have a 0 there. So let's store this. I'm going to store this in matrix Y. Enter. So it's stored. So let's write that here. So that's going to become negative 6 over 5, 7 over 5, and negative 32 over 5. Now, I need to make this a 0, but before we make this a 0, let me go ahead and get rid of that, the 5's here. So I'm just going to multiply this entire row by 5. So, uh, 5 times row 2, row 3, let's store it in row 3. 5 times row 3, store in row 3. Alright, so basically what I'm doing here is I'm going to multiply row 3 by 5. Okay? The sign doesn't matter here. You know why the sign doesn't matter here? Because I'm going to try to make it 0 anyway, so let's just make it an integer and then kill it off. Alright, so to do that, multiply by 5, row 3. So that one is easy. We can even do it by hand. No problems there. 5, 1, negative 2, 12, 0, 17, negative 24, 99. Multiply everything by 5. This is 0. This becomes negative 6. This becomes 7. This becomes negative 32. Bam. Okay? Alright. I gotta bring my calculator up to speed. So I already have this. So what I'm going to do here is I'm just going to multiply it by a row. So go to catalog, multiply row. Remember the syntax. You enter what you're multiplying by, which is 5. The name of the matrix, Y. And the row you're multiplying by, which is row 3. Okay? Enter. Bam, there you go. So let's store it in Y to update what our Y matrix is. Enter. So we're now in the same spot. Alright, now, remember what I'm doing, I'm creating zeros. I have 2 zeros here. Now I need to make this a 0. Alright, and then make this a 0, 0, 0. And then make this 1, 1. Alright, done. Okay? So how do I make this a 0? Let's see. We can use row 2, right? I can multiply row 2 by 6 over 17 and then add it to row 1. Okay? So let's go ahead and do that. So, alright, so the reason why I'm going to be using row 2 is because if I touch row 1, I'm going to change this, and I don't want to mess with that, okay? I have a 0 here, and I want to create a mess. So, we're going to use row 2 because this is already a 0, so when I multiply anything to row 2, this will always remain a 0, so it doesn't change this, okay? So, leave row 1 alone for now. So, I need to change this to a 0, so I multiply this by the number that will give me the opposite of negative 6, which is positive 6 over 17. So what I'm going to do is the following algorithm. I'm going to multiply 6 over 17 times row 2, which makes this number a positive 6, and I just add it to row 3, and that makes it negative 6, 0. And I'm going to store my result in row 3. Okay? So what on earth does this mean? This just means multiply row 2 by 6 over 17 and add to row 3. Okay? Alright, let's do it. So to do that, what we're going to do, we know that everything else stays the same, right? Only row 3 changes, so let's go ahead and write down row 1 and 2 since they remain unchanged. 5, 1, negative 2, 12. And row 2 is 0, 17, negative 24, 99. Row 3, 0. This should be a 0. If not, then I messed up. I have to go and examine my mathematics, alright? So let's do it. Catalog, multiply, and add. So we're going to use mrow add here. Enter, remember the syntax. You enter what you're multiplying by, which is 6 over 17. You enter the name of the matrix, matrix Y. You enter the row you're multiplying, which is row 2, and the row you're adding to, which is row 3. Multiply by 2, add to 3. Let's test it first before we store. Enter. Bam. Exactly what I want. You see a 0 right here? That's what I want. Okay, so let's store our answer. Please do not forget to store your answer or else it's going to be a mess, okay? So let's store our answer in y. Now y is up to speed with what we want to have. So all I just copy down here is negative 25 over 17 and 50 over 17. All right, now what I'm going to do next, how about we make this a 1? If I make this a 1, that'll be perfect because that's what I want anyway. So why don't we just make this a 1 while I add it? All right, and then make this a 1, and then we're going to start constructing zeros from here, and then make that a 0, okay? So how do I make this a 1? I just multiply by the by the reciprocal, and that'll make this a 1, right? So what I'm going to do is I'm going to go negative 17 over 25 times row 3, and I'm going to store it in row 3, okay? All right, that's a piece of cake. We can do that by hand, right? Totally. So what does this symbol that I wrote here mean? It means I just multiply row 3 by negative 17 over 25. This is just a multiplication. We're not adding anything here. All right. All the other rows stay the same, so let's go ahead and write it down. We have 5, 1, negative 2, 12, and then we have 0, 17, negative 24, 99, and then this becomes 0, 0. If I multiply this by negative 17 over 5, it becomes 1. If I multiply, check this out. If I multiply, I'm going to do this in blue, 50 over 17 by negative 17 over 25. 17's cancel out, 25 goes here 1, 25 goes here 2, so the answer is negative 2, okay? So this is negative 2, down. All right. Now I gotta bring my calculator up to speed. So how do I do this with the calculator? Let's go ahead and enter it. We're gonna use multiply, just multiply here. So catalog. The more you do this, the quicker you get. You can do this in a snap. Okay, I'm talking so much, that's why it's taking so long. All right, so multiply. We're gonna multiply row 3 by negative 17 over 25. Remember the syntax. You enter the expression you're multiplying by, which is negative 17 divided by 25. You enter the name of the matrix, y, and the target row, row 3. Enter. Bam. You see what we have? That's exactly what we have. So let's store it. This was just a check. Now I'm going to store it just to make sure that we are synchronized or aligned with our y's. In my matrix in the calculator, my matrix here, okay? Enter. All right, looking good. Now what are we going to do next? I want to start creating zeros. Since I have a 1 here, I want to start creating zeros up here, okay? So let's start with this one. Make it our first target. So how do I make this a 0? I want to create an opposite using this one, right? So I just multiply this by 24 and add it to that, okay? So what I'm going to do is 24 times row 3 plus row 2, okay? Because this is already a minus, and I'm going to store my result in row 2. All right, let's do it. I know certain things remain this. Okay, let me write what this means in word form. Multiply row 3 by 24, add to row 2. Okay? Alright, so let's do it. So we're going to have, I know that row 1 stays the same, so 5, 1, negative 2, 12. Row 3 stays the same, 0, 0, 1, negative 2. This 0 stays the way it is. This is a 0 right here, so it doesn't change that. Let's start predicting stuff. Let's just use the calculator to do it, okay? Alright, so this is multiply and add. So go to catalog, multiply and add, enter. So remember the syntax. What are we multiplying by? 24. We're multiplying matrix y. So you enter what you're multiplying by, the name of the matrix, the row you're multiplying. What are we multiplying? We're multiplying row 3, right? Row 3, and we're adding it to where? Row 1. Row 2. Alright, press enter just to do a real quick check. That's exactly what I want. Notice this became a 0. Perfect. So let's store that so we don't lose it. Store that in y. Enter. Alright, store that in y, so we're going to have 0, 17, 0 right here, 51. Okay, we're getting there. We're finding there, okay? Alright, now we have a 0 here. Now we need to make this a 0. So how do I make this a 0? I just need to look at row 3, double this, and then multiply by that. I don't want to touch any other rows because I'll create a mess. Okay, so multiply this by 2, and I add to that. Okay, so let's do it. So I'm going to do 2 times row 3, add to row 1. That will double this, and if I add it to that, that kills that off because the opposite, and that becomes a 0. Okay, and I'm going to store that in row 1. Okay, so what does this mean? Let's write in word form. Multiply row 3 by 2 and add to row 1. Okay? Alright, so let's see what will our answer look like before we employ the help of a calculator. I know row 3 stays the same, 0, 0, 1, negative 2. I know row 2 stays the same, 0, 17, 0, 51. Row 3 changes a little bit. So this is going to be a 5, this is going to be a 1. This is the only thing that changes. But let's have the calculator do it for us, okay? So don't make mistakes. So let's do it. So we're multiplying and adding. So go back to catalog. Multiply and add is the function we're going to use. Remember the syntax. What are we multiplying by? 2. What's the name of the matrix? Y. What row are we multiplying? Row 3. What row are we adding to? So we're multiplying row 3 by 2, and then we're going to add it to row 1. And let's see what our answer looks like. Bam, exactly what I want. Notice 0, 0 right here. Okay, so let's start answering y, so we don't lose it. Enter. All right, so let's write it down. We're going to have 5, 1, 0, 8. Okay, looking good. Now, let's shift our attention to, this 17 right here. Okay, I want to make this 17 a 1. To make it 17 a 1, that shouldn't be difficult. Wait a minute. Oh, let's create our zeros first, okay? So before I do that, let me go here, and I want to make yeah, you know what? If I make this 17 a 1, and then I can make that a 0 with ease, as opposed to making this a 0 first, because that's going to be too hard. So let's make this 17 a 1, and then I can use this to make that a 0. That was quick. I think that's better. Alright, so let's do this. So let's make 17 a 1. So to make 17 a 1, all I'll just do is I'll multiply this entire row by 1 over 17. Okay? That's a piece of cake, right? So 1 over 17 of row 2, we're going to store this in row 2. Okay? So let's go ahead and do that. So if I do that, I'm going to have, what am I going to have? I'm going to have, this one I can do by hand. So let me write what this means first and then do this by hand. So multiply row 2 by 1 over 17. Okay? So that means this is divided by 17. So what's that going to look like? Well, if I do that, this is a cake. I'm going to have 5, 1, 0, 8. And this becomes 0 divided 17 by, multiplied by 1 by 17, that becomes 1. 0, 1 divided by 17 is 3. 0, 0, 1, negative 2. Wow, this is looking beautiful now. Alright, well, we need 2 more steps. I need to make this a 0 and then make that a 1, okay? So how do I make this a 0? I need to look at this, get the opposite of that, and multiply it by this, okay? So to do that, I'm going to multiply, I'm going to do, let's see, I'm going to say negative 1 times row 1, times row 2, and I'll add it to row 1. Alright, and then I'm going to store it in row 1. Okay, so before I move on, let me show you that in the calculator. I know you already have a hang of it with the calculator, but you're just going to keep up with the whole procedure. So I multiplied row 2 by 1 over 17. So let's do that here real quick. Catalog, multiply 2 in matrix Y. Actually, multiply 1 over 17 in matrix Y. What row did we multiply 1 over 17 by? Row 2. Do a check. Perfect, exactly what I want. So let's store it in y. Y is up to speed. All right, so now what we're going to do is what I said earlier. This I can do by hand, okay? But I'll just show you the calculator. So let me write out what I'm doing. I'm going to multiply row 1, actually multiply row 2 by -1 and add to row 1. Okay? Alright, so let me show you what that looks like. It's going to be row 2 and 3 stays the same. So row 3 is 0, 0, 1, -2. Row 2 is 0, 1, 0, 3. Now row 1 is going to change. Okay? This one stays at 5 because when I multiply this by -1 is 0. I need to change that. This one becomes a 0. This one is still a 0, but -3 plus 8 is a 5. Okay? And then to finish it up, we just divide row 1 by 5. So to finish this up, I'm going to do 1/5 of row 1, storing row 1. I don't need to use a calculator anymore. I think you already got the hang of it. So multiply row 1 by 1/5, and your final answer is going to be, divide that by 5. Multiply this by 1/5 or divide by 5 is going to be 1. Everything is 0, 0. If you divide 5 by 5, it's 1. This one doesn't change, 0, 1, 0, 3. And this doesn't change either, 0, 0, 1, -2. And there you have it. There goes the reduced row echelon form. You notice how when we did it with the reduced row echelon command, it did it in less than a second, right, to get this answer. But if we want to do all the matrix operations, it takes forever, but it shows the steps, you know. So there goes our final answer. So our solution is x equals 1, y equals 3, and z equals -2. Okay, so there you have it. So thanks so much for taking the time to watch this video. Please subscribe to my channel by clicking up here. You can also share this with your friends via Facebook or Twitter. More videos can be found on mathgotserved.com. You can also request free math help at mathgotserved1, and that's my Twitter page. Thanks again for watching this, and have a wonderful day.